This Week in Radio Tech, episode 304, is brought to you by Axia and the convenience and flexibility of LiveWire Plus, with over 100 partners and products that work with LiveWire. By the new Omnia 7 AM audio processor. Truly, AM never sounded this good. And by Lavo and the Crystal Clear virtual radio console. Crystal Clear is the console with a multi-touch touchscreen interface. Chris Tobin joins us with a full-hour live remote broadcast from a park in Newark, New Jersey, and he's not using his telco's carrier data. It's just another way that Chris is demonstrating that broadcast engineers can get it done for remote Wi-Fi. Chris reveals his methods and secrets on this episode of TWiRT. Welcome into This Week in Radio Tech. I'm Kirk Harnack, your host. Delighted to be here. I can tell already it's going to be a fun show. This is the show where we talk about broadcast audio and RF engineering, the things that have to do with radio, getting audio from the microphone where people talk, and guitars where people play, and stages where people sing, and usually it's records and CDs and automation and digital files. Get that all the way to the transmitter site and try to blow it up the tower at 50,000 watts, 100,000 watts, whatever it takes, whatever we're licensed for, and cover the neighborhood with the signal so that people can pick it up conveniently. That's what we do. And then of course radio is getting into all kinds of other things like television and streaming on the internet, making a big presence there. As usual, I'm in my office here in Nashville, Tennessee. I'm the host of the show. As a disclaimer, I work for the folks at the Telos Alliance. So if you hear me talking positively about them, it may be an ad, or it may be me just talking. Also with us is our usual co-host. He's not unusual. He's usual. Is our co-host, Chris Tobin. Chris, welcome in. Glad you're here, buddy.
Thank you. Yes, I'm in my outdoor office with the squirrels and birds and Mother Nature. I'm going all green. I'm going to be a LEED certified podcaster. That's what I'm going to go for.
That looks
I'm
really nice.
operating on battery right now. I'm not connected to the grid. Everything is good.
Can you tell us where you are in the city, the Big Apple?
I'm in the city of Newark.
Oh, you're not in the Big Apple.
Yeah.
So
I'm actually connected on my Ubiquity device, that is.
Yeah, I want to hear about that in a minute. But whenever there's trees, I always just assume you're in Central Park, because that's the only place in New York where I can know that where there's trees. There's places other places too.
There's Prospect Park in Brooklyn too. I've been there, and there's a couple other parks actually. I think I'm going to do a park tour. That's what it's going to be. This week in Radio Tech parks.
See, I'm just a tourist. I don't know all this stuff. I know where Central Park is because you can see it from space. So I know where that is.
You can see a lot of things from space.
Yeah, that's true. That's true. If you look hard enough. So hey, Chris, welcome in. Glad you're here. And is it chilly there? You look dressed a little warmly.
Say again.
Is it chilly there? You look dressed a bit warm.
No, it's not chilly. I'm just wearing a nice jacket for image purposes. It's very comfortable. It's about 68 degrees. It's a nice breeze. Squirrels running about. So if suddenly I dip down out of the camera, it might be because the squirrel's coming after me.
Hey, one of our previous guests on the show, Sherry Barclay, she runs that station. I'm almost embarrassed to say the name of it. It's kpiss.fm. And Sherry posted something on Facebook the other day about why black is the color of dress in New York. Why everybody wears black in New York, or seemingly everybody. And it's a really interesting article. It's got a lot of history. It goes way, 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 way back to some dignitary or politician who kept wearing black after a prominent funeral. And it's become, the color of power and slimness. Although New Yorkers tend to be slimmer anyway, all the walking they do. So do you find black is the thing to wear in New York yourself?
Me, no. I just happen to be wearing my little black pullover today, but no, I normally do not wear black. Being part Italian, black is part of the heritage, so yeah, it's probably black.
That's right.
But it's true. That story, the black fashion in New York City has gone on for years. It's every year there's a fashion show, and there's always some reference made to black, and New Yorkers only wear black.
Yeah. Yeah, I've watched or have noticed that, and you just can't go wrong wearing black there. Normally, I'm not aware of attire faux pas. I can tell you that if you go to Paris, My wife and I went to Paris a few years ago, and she made apparently the unforgivable mistake of wearing sneakers.
Oh yes, no, no,
Oh
no.
no, we didn't know. We didn't know. She got a lot of dirty looks the whole time. Anyway, I forwarded the article that Sherry Barkley posted about black, because my wife wears black. That's just that all of her outfits are black. She has nothing but black outfits. So there you go.
That's great.
I didn't know you could buy black in so many different fabrics. It's amazing.
Oh yes, you go down to Broome Street or Broome or Spring Street in Lower Manhattan, and you'd be surprised the amount of black fashions you can find in the fabrics, styles, textures. There's a lot. Yeah, there's more than you ever could imagine.
So, Chris, this is going to be one of these fun shows when you and I just actually get to have a conversation about different things that are in the news, certain times of year it is, little tips and tricks that we've learned. I've got a number of things to bring up. And so we'll just play it by ear. And if you've got something you want to bring up, I know you do, about your connectivity. We're going to get to that right after our first spot. I want you to describe that, and probably you're gonna bolster my opinion that if you want internet somewhere, by golly, unless you're in Antarctica, you can probably get it. And you can get it there too. It's just not very fast. So our show this week in Radio Tech, the episode number 304. Can't believe we've been here this long. It's brought to you in part by the folks at the Telos Alliance and Axia. And what I want to, we talk about Axia on every single show. And I want to spend a moment on this show telling you, reminding you about all the partners that are involved with Axia and the Livewire standard. Now, many of these partners are also moving into AES 67, but things don't happen overnight. Maybe you've got a studio to build now. Well, go ahead and outfit it with equipment that speaks Livewire now and is beginning to speak AES 67. They're very similar, not the same, but they're very similar. And that way you'll be able to add more and more gear as the years go by. That'll all be compatible. So anyway, these partners. Early on in the history of Axia and Livewire, we figured it's pretty important that Axia gear not just talk to itself. Right? I mean, that's good enough. I mean, consoles and consoles and nodes, I guess, and the network. Okay, talk to itself is fine, but really, what's important is for Axia equipment via Livewire, an audio over IP standard, to talk to other stuff that you want to connect it to. That's where it really brings in the convenience and the ease of use. So there's a few partners people that have partnered with Axia through Livewire, and I'm gonna mention just a few of them here, because a lot of these some you may not know. A lot of these may be European companies as well, so you may not know them from that point of view. But here are a few. How about AEV Broadcast? It's an Italian company based in Bologna, Italy. How about Audio Vault? That is compatible with Livewire. Avra, that's audio for video and radio. Audio and video for radio, I should say. Avra, they are a Latin American company. Axel Technology, they're a premier manufacturer of radio and television broadcast solutions. Like they also do a lot of system integration. Of course, Broadcast Electronics, makers of the aforementioned Audio Vault. Broadcast Partners in the Netherlands. BSI, that's Broadcast Software International, maker of the famous OpX automation system. Burley Software for newsrooms. Dabis Software. Dowlette, you've heard of Dowlette certainly. David Systems, yes, I'm kind of going by alphabetically here. Digispot, which is a German automation system. Digimedia. Digital Jukebox. Digaton. Enco. Fraunhofer makes stuff that talks directly to Livewire. Hard Data, which is another workflow solutions developer, and they are in Argentina. Innis Corporation from Australia. The list goes on and on. Netia, OMT, we mentioned OpX already. Pristine Systems, RCS, Rivendell, Sterlitz, Synodin, Wide Orbit, Vox Pro, Win Media, Wire Ready, and Xenon Media. And then there's hardware development. That's all software. There's hardware development partners as well. They make boxes that just plug right into Livewire, like 25/7, which then Telos Systems acquired. Audmax, Audio Science, Digigram, Elenos, International Data Casting, Logitech, Maya, Nautel, Paravel Systems, Ravenna. Paravel makes an audio router, not just the automation system, but they make a hardware audio router box. Sound 4, Studer, Wegener, and XI Audio. And then there's a ton of system integrators. My point here in pointing all this out is that LiveWire began 11 years ago and quickly brought in a bunch of partners so that you, broadcast engineers, and me too, would have a lot of options in just connecting things up. We wouldn't have to just run a lot of multi-conductor cables. We wouldn't have to use a whole lot of the X nodes that you may need to connect into systems that I didn't just mention just now. So you've got a legacy satellite receiver that needs to go into a LiveWire system. You've got to connect through an X node to convert it from analog or AES into LiveWire or AES 67 format. So if you have equipment that already speaks this, then wow, you've got a real benefit there because you can just plug it in and configure it, and now, bang, it is on the network, already talking LiveWire. I just want to point that out because that is an effort that the folks at Axia made very diligently starting 11 years ago in getting partners on board. And you know what? Some may argue, well, hey, Axia, you could have made more money if you just sold a lot of nodes. And that's how you connect to other people's gear. And that's true. That's true. Probably could have made more money doing that. But, we got to look ourselves in the mirror every day. And we have to realize, what are we doing that's the best thing we can do for engineers and broadcasters? And it was a heck of an effort over the years. And, we still do it. We still bring in partners. But bringing in these partners makes our jobs easier as engineers and as broadcasters. And I, for one, really appreciate it. I've mentioned my radio stations. We've got hardware and software that plugs right into our Axia LiveWire system. And hey, if you're a public broadcaster, well, you've got equipment from International Data Casting that plugs right in. And if you have almost any automation system, you've got it too. So I just want to say hats off and thanks to the folks at Axia for all that effort they put into making their equipment and other equipment compatible by bringing in all these partners so that engineers and broadcasters can benefit and have, honestly, an easier time of doing their jobs. Thanks, Axia, for sponsoring This Week in Radio Tech. Appreciate that. Okay. Hey, it's Kirk Harnack along with Chris Tobin on This Week in Radio Tech, episode 304. Chris, you being out in this park now in Newark, I'm curious how you get an internet out there. I think you're not using your usual Verizon 4G card. You got another plan going.
That's correct. I decided to try the Ubiquiti M5, the nano station, and I'm extending the LAN from a local office here to test out the idea of if I was a broadcaster that it was looking to work at a venue and I didn't want to, use the 4G wireless data modem as my primary link, but maybe as a backup, can I extend a LAN from, say, the park offices, or maybe my studios are located across the street or down the block from a park that I've been doing a broadcast from for a venue, or not, maybe not a park, maybe it's an entertainment venue, performance center, whatever. So I thought I'd try this out, and this is strictly default settings, straight out of the box. I'm about a half a block away as the crow flies to the access point. I'm using the Wi-Fi on my MacBook. And I have a speed test. So if Suncast would bring up the first slide, if you will, and you'll see what the speed test revealed. And this is on the 20 megahertz setting for the AP, for the access point. So not to try and do too much of a high bandwidth and get all kinds of crazy stuff. The higher you go, the lower the data rate as far as passing that through. That's Shannon's law. We'll get into that in another episode. So it works. It works really well, and that's what you're seeing me do right now. So I'm sitting in a park. Behind me is just some flora and some squirrels running about, and it's working really well. So if I was doing a concert here or an afternoon event or a weekend or night, I could probably do it very successfully because I'm controlling my link. It's my 5.7 gig or 5 gig unit, and I can use a wireless Verizon card, AT&T, T-Mobile, Sprint as a backup. So what that means is I could be using a router a dual WAN router that has Wi-Fi capability. Use that as the in, and then the backup is the other WAN port, and off I go. So I've got something going on. And the reason I'm doing this is not because I just like the idea of having fun doing this, but I'm looking at it from a standpoint of making money. If I'm a radio station, even TV, but let's say a low power FM or FM broadcaster or even AM, and I need to generate revenue because that's what we do, this would be a way to do it in a sort of a minimal barrier event. So sometimes you just can't afford to be putting in DSL lines or ISDN, or if you even get the ISDN anymore.
Wow.
I thought Kirk, you were saying
Chris,
something.
no, I was about to ask a question about the speed that you showed us was about 36 down, 27 up, something like that.
Yes.
And that is all the way back to wherever that speed test server is. So which is in Secaucus, I think it says there.
That's at Secaucus, yes.
Yeah, so it's local. I mean that is the path to the building that's not far from you and their internet. So but you're testing more than just your radio path. You're testing all the way back to a server somewhere.
That's correct. So the second screen, the second slide you'll see is a wide shot of where I'm sitting, looking at the space between the buildings where the access point is mounted on a pole on the rooftop. And when that pops up, you'll see that. And what do you call it? It's interesting because it's a 44 or 45 megabit service at the office, 45 megs up, 45 megs down, so it's symmetrical. So you're looking at what I am getting out of the bridging of the LAN. So it's more than sufficient for audio. It's even, it's even sufficient for video. So we're doing Skype video right now, and that's typically around 3 megabits for the HD. So that's what you get. And so the second, did I miss it? The second slide. There we go. So it doesn't look like much more than just a space between buildings, and that's just the little square in the center. Is the little white dot is actually the M5.
Okay,
in the distance.
All right.
so let's go to slide number 3.
Yeah. Okay, we'll go to the third slide then.
What's that?
We'll see. We'll go to the third slide here. All right.
There you go. So now you can see a little more of the white dot, and that is it. So I'm a distance of about, I guess it's half a block, 3/4 of a city block from that. Now remind you, remember, now we're doing antenna principles RF. The M5 is 13 dBi forward gain. It has a beam width. Remember, beam width is this guy here, the left to right and front. I believe is about 10 degrees, or maybe I have that wrong, 15 degrees. So what I did do a test was, let me go off axis from the center of the M5, and sure enough, the data rate dropped from what you saw in the first slide to just about DSL speeds when I was no longer line of sight. So it definitely shows that if you're not line of sight, you lose your data rates. But that's okay. It's predictable. That's the test you want to do. You want to be able to find out what your window is, what your beam width, where can I place my remote set, my setup. Do I stay within certain location, and I know I'm good. These are things you do, site surveying, and once you do that, you establish it and do several tests. I did 6 speed tests. They all came within about 3 or 4 megabits of each other, and I tested different servers around the country just for fun, and it worked. And you're watching the video right now. I'm talking to you over the Ubiquity link, and it seems to be holding steady.
So I've got a ton of questions, and hopefully people in our audience are thinking some of the same things I am, and I'm thinking what they're thinking. All right, several questions. Question number, so did you break into this office and just tell them you needed their bandwidth for a while, or do you have friends there?
No, I have friends there.
Okay, good. All right. So you scoped out an office from which you could aim this signal to a comfortable place to do your show from, right?
Yes, absolutely.
Okay. All right. Cool. Now, the unit at the office, that's where you're picking off their bandwidth. It's part of their network, right? And I imagine you've got these radios in maybe a bridging mode, so your laptop now picks up an IP address, and it's part of that office network. Would that be right?
That's correct.
Cool. So the unit at the office on the building there, now that's powered over PoE, power over Ethernet, and you've probably got a power adapter there. How are you powering the one where you're sitting in the park?
Oh, where I'm sitting in the park? Maybe we missed all that part. I'm using the Wi-Fi adapter in my MacBook. I'm not doing a point-to-point. I'm doing the worst-case scenario. No, if I did the point-to-point, that's cheating. That's easy. Yeah, I can make those point-to-points work.
So you just made just a Wi-Fi hotspot and it's
Directional
not in
hotspot.
a directional hotspot. Okay, but
Yeah.
okay. I thought you had a little pole out there with another nanobridge.
No, that's going to be another netcast. I have that all set up in the back in a bag. That'll be a couple of episodes away.
So you're just using the 5 gig Wi-Fi in your
Yes.
laptop for this? Okay.
Yes.
Duh, makes it. So is this 802.11n or is it A or C? Do you know what standard it is?
It's 802.11. I think it's A. It's the 5 gig.
Okay.
5 gig is A.
Oh yeah. Okay.
28 megahertz data rate bandwidth. Yeah.
Now, just
I
curious,
wanted to purposely do
Yeah.
a worst case, and I should say worst case.
Yeah.
I wanted to be able to do like an ad hoc situation. Say you're a radio station programmer and you suddenly get an opportunity to do something in your community, and you've got your access points up on the rooftop because you've done something in the past with a point-to-point. Now you
Yeah.
could run out and do something real quick on a laptop, webcam, and or an IP audio codec, whatever device, and get it back and get on the air and do stuff and make things happen. So you got two choices: fixed permanent point-to-point for planned, and the ad hoc that you can get away with for quick hits if you want to do something spontaneous.
Yeah, okay. I totally got it now. You made a, by golly, commercial grade and very directional Wi-Fi hotspot at a friendly office where you could hang the thing out the window, I take it, and point it toward the park.
Yeah, it's actually on a pole on their rooftop. They have a
Okay.
They have a GPS for an NTP server, so I mounted it with tie wraps to the pole, and it's pointing through the alley to the park. And I just, like I said, I figured out the spacing, the bandwidth, the beam width that is, and I'm within the beam width. So if I look over my shoulder looking for the tree, there's a space between the buildings, and that's where I'm looking at. So I'm at the very edge, if you will, of the, if you put a triangle on its side, the very point of the triangle is the access point. So I'm on the left side of the triangle. I'm just at the edge of the beam.
Gotcha. Okay.
Yeah.
Well,
so
thanks for explaining that. That is awesome. So the only batteries you need are the batteries that are in your laptop, and it thinks it's on Wi-Fi because it is.
Right.
Okay.
So the idea behind this is just to be able to say, hey, we can do it, and you just have to plan it out. That's the trick.
Well, I kind of forgot that, I think of these Ubiquiti and other IP radios as strictly point-to-point, that you need two of them pointed at each other. But you got to remember, they are just using Wi-Fi. Now, there are some additional tricks that can be turned on and implemented. Some TDMA, some time domain multiplex. If you're, for example, a WISP, a wireless ISP, and you want to give appropriate time slots to certain customers, then the radios often have that kind of thing built into them, so that there isn't signal strength or data contention. There is a time slot where your radio gets to talk to your wireless ISP. So I guess you're not using that kind of function. You've got it set up just as a hotspot.
Right. And I purposely, again, did that. It was intentional. If I was doing a broadcast in this particular scenario, I would do the point-to-point ubiquities so I could take advantage of the AirMax protocols. So for the TDMA, the FTTT, all the different features they offer. Yes, for critical broadcast, fixed position, planning, definitely go point-to-point. But then you're guaranteed a really good carrier class approach. But if you need to do an ad hoc because it's just one of those things, at least you know this scenario can work and you can make it happen. And that's the point behind this exercise, to demonstrate both sides. Because I've worked in so many radio stations where programmers would come to me and say, hey, we just got this opportunity to do X. Do you think we can do it in 2 days? I'm like, oh, wow. Let me see what we have in the back. So, when you do these things now, you could say, yeah, we can, but here are the restrictions. And then this way, you're working with the programmers, the program directors, and they say, okay, we know there's restrictions, but at least we can be there. Fine. Well, let's make it happen, knowing there's a caveat of good or bad. Whereas in the past, we used to do things and go, sure, we can do it. 2 weeks, got an ISDN line in, we're done. And then something goes wrong, and the programmer screams at you like, what the hell? We had 2 weeks to get this working. So keep that in mind.
And if you had to have a backup, you would probably use a Verizon 4G data card as a backup.
Absolutely. That's the best part of this whole thing. You can get a nice little, wireless router that has Wi-Fi built in, make that pick up the access point. That's your primary. And then you can fail over to your second WAN port as a backup. I mean, how cool is that?
One of the questions that, and years ago when I was setting up remote broadcasts using Marty's and some paid for, nailed up dry loops or equalized phone lines, I would ask if they wanted to do a remote from this place or that place. I would end up asking, do we know anybody in that building, or do we know about anybody in a nearby building? And that was usually to find a good place to get the Marty shot out, or if we had to just do something really unusual. We did one remote, I've mentioned it before on the show, where the short story is, do I know anybody who owns that tower 26 miles away from our studio? Because that tower, besides being a cable company head end, also had a Marty 450 megahertz antenna that was normally used for receiving. But for a few hours on a Friday, we used it for transmitting. And it transmitted right up to Lexington, Kentucky, and got the remote on the air. And then we got a nailed up wire line from the bar from which we were broadcasting to that cable company head end, and then we had audio to go into the Marty transmitter. Worked like a charm. So you were still, when engineers today are doing planning remotes, like what you're doing, we're going to ask ourselves, or ask the other staff members, do we know anybody in a nearby building that's close to where this venue is that we're doing, or in the venue itself, of course.
Sure.
So,
well,
yeah.
that's what's great about this technology. In this case, the M5, the NanoStation M5. Before I start using it as an access point, I turn on the spectrum analyzer feature and take a look at the spectrum. So now I can look at the spectrum where my antenna is going to be located in this office, this alleyway between two buildings. It's only about 30 feet above the ground. We're not talking 60, 70 feet. So it's 30 feet. It's shooting between buildings, going across a rooftop. So you got Fresnel zone issues, another episode we can do. And you could look at the spectrum and say, okay, this is a relatively quiet spectrum, or the noise floor is such that I can overcome it. And the nice thing is, because it's directional, I can now go out to my remote location where I'm sitting right now in the park and do the same thing with an application on my laptop to look at the spectrum and say, oh, good. And you can do the math. And once you know where the noise floor is, where your carrier level is going to be, you're up and running. So I'm running this unit at full 23 dBm, which is about 0.193 watts. It's nothing. But at 5.8 gig at, at 13 dBi, that's probably the ERP of like 3 watts. So it's at 5 gig, that's a lot. And this is what I got. And I got a MacBook sitting on a table, picking up the signal. It's between the trees and in a building. So it's working out nicely.
So this M5, it's the NanoStation M, and it's the 5 gigahertz version. So does it look like a big candy bar? Is it just kind of tall and flat, or is it something else?
Yeah, no, it's rectangular. It looks like a Wonka bar. It's about 6 inches. Yeah, 6 inches long, 3 inches wide, 2 inches wide. Yeah, real basic.
Okay.
It's an indoor-outdoor unit. It's a basic unit. It works really nice. I have 2 other models I'm going to play with in the next few weeks that get a little more involved, so it'll be fun.
Gotcha. Wow. Cool. It's a great world we live. And I bet that thing was cheap, right? Was it? Under a couple $100?
It's a couple $100, not even. I've had it for so long I forget now, because I think this particular model they stopped making. They redesigned the housing. The same technology's in it, but they changed the housing for the usual stuff. The cost of entry is minimal compared to what it's been in the past. So you can't go wrong. It's really cool.
A few weeks ago, you showed us another product from Ubiquiti that you used for some troubleshooting. I believe it was a Bullet M. Is that right?
Yes, that's the other unit I'll be playing with an Omni 5.8 gig collinear antenna. I'm going to stick on that. I'm going to try and see how that works out.
Gotcha. Because you can put that into a small dish antenna. They make all kinds of different dishes.
Oh yeah,
you can run that into.
Oh yeah. The nice thing is, because it's PoE at the rooftop right now with the M5 it's just one Cat5 cable stuck out the window, up across the roof, and then plugged in. It's great. Didn't have to look for an extension cord, plug into anything.
I've got to double check this, but some months ago I installed some new Air Fiber 5 systems in Mississippi, 13 miles apart. One of them, these are the dual dish thing, so it's full duplex, full-time transmit, full-time receive, and 13-mile hop to a transmitter site. It's on the air. We got 2 stations on now. We're about to have a 3rd station on within a few days. And but I I didn't fully take advantage of something. I got lazy. I made a mistake. I ran one Cat 5 up to it. It has 2 jacks. It has a management jack and a data jack. And I really wasn't sure, well, why would you run 2? You can just do the management over the data. You can, but not if you are trunking. Not if you are hooking the data to a trunk port on a Cisco switch. Then you have no access to, because it's not an access port, you don't have access to talk to the air fiber itself. So I've got to go back and run a second Cat 5 cable, which I kind of feared. I didn't know why, but I feared I'll probably have to in the future. So I will, because in the future we're going to have to make that that radio system to do trunking so that we can better handle the live wire and the IGMP groups and divide it up into bandwidth usable for other stuff too. At least I'm told that's the thing to do.
Yeah, I learned a long time ago in my first Axia installation, if I have a device that has 2 RJ45s on it and I'm running cables to it, I make sure that I have cable runs for every RJ45 that's on that device.
Well, yeah, you think
I ran into a few situations just like you're finding out, where I was like, wow, if I had the other management port, I was using it in that use that other port as a management port, I can actually troubleshoot, shut down the other port, do things, and not lose my connection. Wow, what a thought. And yes, I learned that early on, many, many years ago. Today, I do not do that now. I make sure if I have to, I'll run an extra cable. Matter of fact, that's what I did on a project a couple of weeks ago. So it pays off.
I had a gut feeling I was making a mistake, but I was, climbing the tower on my own, tired, and I got a million excuses. But I'm going to have to go, run a second cable, which also implies a second set of, grounding kits and surge suppressors, and probably a second set of media converters to run a little fiber link to electrically isolate it from everything else in the station. So it'll be several $100s just to run a second cable to each unit. Actually, it'd probably be over $1,000 for a second cable to each unit.
It's always cheaper to do it the first time around rather than come back.
The cost would have been the same, and you know what? Actually, I've got some more grounding that I never got done that I need to go back and do anyway. So it's really okay, but leave it to me to say it'll work without that. I tested it. Okay, but you're gonna have to go back and do it. So, hey, you're watching This Week in Radio Tech. Our show is number 304. Chris Tobin is with me, Kirk Harnack, your host, and we are just dishing on some technology items. And that was a great lesson from Chris in how to another way to do a remote. And I'm glad he cleared that up for me, because I thought he had 2 of these units. So he's just got him a honking Wi-Fi hotspot with a directional beam.
Going commando.
That's right. That's right. But we'll have plenty more to talk about in that regard, and also an interesting bit of confusion at the Dayton Hamvention. That's been going on. Is it over yet? I'm not sure, but anyway, there's an interesting story about that. Hey, our show is brought to you in part by the folks at Omnia, and we talked about it last week. I'm going to talk about it again this week because I've got to send the box back to my colleagues at Omnia. I'm going to take my camera here. I know this is not very professional looking, but I'm going to take my camera here and point it over here at my rack, my equipment rack. There we go. And you can see, now that looks the same as what an Omnia 7 FM, which we've been advertising in the past and playing with. Let me get there we go, get the camera. But look, on the, up there, it says, can you see it? Now you probably can't see it. It does say Omnia 7 AM there. Lighting in the studio just doesn't favor that. Okay, but it looks like an Omnia 7 FM, but it's an AM. Now, believe it or not, there's a lot of stuff that's different in this box, and there's a lot of stuff that's the same. Treating audio really well and making it sound good, a lot of similar concepts in AM and FM. The first concept for making AM sound better, just like FM, is to get rid of clipping and distortion. And so this has the undo feature, which gets rid of the hyper compression that we find on so many songs and even on microphones and services. And it also has the declipper from Hans von Zutphen. Hans has been a guest on our show where he kind of explained what he could about how his declipper works. And it's amazing. It really cleans the audio up and gives you back nice, clean audio. Then you get to process that audio the way you want to, not the way somebody else thought it would be a good idea. And this works really well. So after it goes through the undo and the declipping, then it goes through, a 3-stage AGC, automatic gain control section, with a stereo width control. It also goes through a multiband compressor and limiter, but you get to control it. You get to decide just what its texture and sound is going to be like. And then it goes through, and let me see if I can say this right, because this is tough. This is tough. A psychoacoustic. That means it changes depending on how you're going to hear it. A psychoacoustic distortion masking clipper. It really can do an amazing amount of clipping and hide the distortion. You'll never hear it. Well, you'll hear it if you just crank it, all the way up. But it's just amazing how much you can do, how much loudness you can get out of this box, the Omnia 7 AM, and it doesn't sound distorted. It doesn't even sound uncomfortable. So I've been playing with this thing. You can see this is the screen where you have the displays full screen on the front. And by the way, you can get all of this information remotely with the NF Remote program that comes with it, that we supply. You can connect to it over any IP connection, any speed. If it's too slow, you won't get some of the higher speed displays. If it's fast enough IP connection, you'll also get audio. You can monitor audio going in, audio coming out of this thing, even monitor. If you have an external mod monitor at your AM site, you can take that audio, run it into the Omnia 7 AM, and listen to it back at wherever you are, wherever you're running NF Remote. It'll automatically get to you. And if you have an adequate IP connection, you'll get that audio coming back linear. It's just amazing what is built into this box. You can see the 10 kilohertz low pass filter on the spectrum display in the lower left-hand corner there. So there's all kinds of displays you can set up. There's even a time loudness graph. That's the lower right display that shows you loudness in LKFS over time. You can see, hey, we had a segment that was really low, or well, this guy's getting into it. Getting into the meters a few times there. It's an amazing processor. I've been playing with it now for several days. I'm going to take the camera off of that and return the camera back to where it goes here. There we go. Hopefully I'll get about the same framing. So this is something, why would you make a new AM processor, people have asked? Well, because nobody's made a new one in years. And there are some very old AM processors out there on the market and at transmitter sites. Processors that haven't had much improvement done. So if you got an AM station and you want it to sound really, really good. And by the way, this is on the air at a number of beta sites before it went on sale just a few weeks ago. And at these beta sites, I've heard some feedback that, well, let's just say the engineers are really happy. They are loud and very clean. It's very listenable. Not fatiguing to listen to. Thanks again, Omnia, for sponsoring This Week in Radio Tech and the Omnia 7 AM. Check it out at telosalliance.com. Click on Omnia and look for processing and look for the Omnia 7 AM. By the way, you'll really enjoy the price. It's pretty amazing. Same as the Omnia 7 FM. Options available too. I guess I could go on and on, but I got to stop sometime. All right, Chris, it's episode 304 of This Week in Radio Tech. Delightful instruction there on what you've set up and how it works. And you said that you used the spectrum analyzer function before you got going and looked for interference, looked for other energy in that 5 gig range, and you were kind of impressed with not seeing a lot.
Well, yeah, I mean, you'll see a lot. You'll see stuff. The trick is understanding the noise floor, where you're working with noise floor, looking at the spikes, and with the spectrum analyzer or the what do they call it? There's a name for the program, and I can't think of it now. But you can look at it over time. So it does a waterfall graphic. So you can look over time to see how much energy comes up and down and how often it stays up. If it's just periodic little spikes here and there, that's just people passing by, probably with phone devices or whatever. But if you see something like the haystack look of a spectrum on where you are, then you've got something steady. So you want to stay away from that. You look at the frequencies it's operating with and you stay away from it. So those are the things you look for. It's just like you would do a spectrum test, say, at a multi-antenna site or a multi-transmitter site for FM or even AM. So that's the great features here. And once you understand the lay of the land, you go with it. And one thing I wanted to point out, which I didn't do earlier. This setup that I'm using would be the same thing I mentioned some time ago on many episodes back. Say you're doing a broadcast from a sports bar or some indoor event, and they have good internet. Okay, we'll call good internet connectivity. The bandwidth is just right. Tests really great. It's a wired connection at the router you're plugged in or the switch. The problem is your broadcast location is on the other side of where the switches are located, and running a cable is either cost prohibitive or a safety issue because of trip hazards.
Yeah.
Use this method. You take your little M5 or whatever you have, you place it near the doorway in line of sight of where your broadcast spot is, and you take the other one and point it to it, and now you've got yourself an RF link between, and you're on the air.
Yeah.
And you use the same spectrum analyzer software to look at what's going on inside the bar, or if it's a bar or a bookstore, wherever you are.
Sure. And I guess, if you have several devices to use, and maybe one of them is a wired device. Maybe you've got I work for the company, so I'm going to think of it. You've got a Telos Zip 1, which you can run Wi-Fi, but it's so much easier to plug in the wire. You could have the other end of that Ubiquiti system, so you could have a client end, if you will, and just run that into, honestly, a $29 router. And give yourself a whole new range of IP address, or just into you could just run it into a little hub, a switch. Honestly, a $19 switch would give you typically 4 or 5 ports there, wired ports that your equipment
or you
could be
just
on.
plug it directly into the back of the M5, and you've got a nice point-to-point connection, nothing else to worry about, and you can still access it because you can be on the LAN. Because I'm using right now my iPhone's Wi-Fi on the same link that I'm using to talk to you for This Week in Radio Tech. So I've got 2 devices right now on my Ubiquiti connection. So I can actually use this little iPhone and access my Ubiquiti and see how things are going without interrupting my Skype connection. So these are the things you have to think about.
Cool. So earlier, and Chris, if you think of anything else you want to tell us on that, just jump right in with that. I wanted to point out, we talked about this before the show, actually, before we started the show, so I'll point it out again now, that there is a group on Facebook. Facebook it's the 3rd largest country in the world, right? So like 1.5 billion members, and there are almost a billion. It's just barely shy of a billion daily users of Facebook. This is not a commercial for Facebook. I know it's got plenty of foibles. Who knows? In a few years there may be something else that comes along that's better. But I'm sure they're trying not to let that happen. But one of the good things is you can have interest groups on Facebook, and of course 99% of you are listening probably are already a member of some interest group or another. And one of them is I take pictures of transmitter sites. Now, it's a closed group. You have to ask permission to become a member, and they're pretty strict about what you can post and what you can't post. It's got to have something to do with taking pictures of a transmitter site. But hey, a cell phone, in the right circumstances, can be a transmitter site. So there's a few things in there. There are a lot of topical things that people are posting. One thing is it's springtime. Weather's can be good here and there. And so for some folks, it's time to do their annual NRSC measurements on AM stations. Still got to do that. And you have to take the best way to do it is to take an antenna of a known sensitivity and known response across the frequency band and hook that up to typically a spectrum analyzer and measure the mask of measure the energy of a given AM station. There's a lot of variables there. There's a lot of tricks that you may have to do in the field to actually make it work right. But Tony Dinkle is a member of this group, and Tony's a great engineer, and he posts a picture of his Chevy pickup truck with a tripod in the back and one of the famous Chris Scott calibrated AM loop antennas on there, and I'm sure he's got a spectrum analyzer nearby. So he's out taking not monitoring points, NRSC measurements at various transmitter sites. Chris, has been a while since you've done an NRSC measurement yourself. Or you still called on that from time to time?
I'm still called on it. I haven't done it. Oh gosh, it's been probably 8 months since the last one I did. Yeah, maybe 9 months. Yeah. I still get. I work with an engineering company, part-time basis, and I usually get called in for some of the broadcast stuff.
Gotcha. Yeah, I did those, and man, it was so often just really tough to get your mobile, antenna and spectrum analyzer situated in a place that was free enough of noise, free enough of big signals from from other other signals that may interfere with it. And sometimes you may have to pick an interesting time of the day to get the measurement done, where you're just not getting interference from other signals. That was my experience. Anyways, sometimes tough to find a good spot.
It is tough. It's not easy, and every location is unique. So what works in one will not work in another. So yeah, you just have to get there early, look at the spectrum, look at the environment you're in, and take it from there. It's not an easy one to do.
Now that we're through the winter, a lot of engineers have been out making some inspections on their towers, and especially AM towers. AM towers, some of them have a lot going on, mechanically speaking. And over the years, maybe things have been added to the tower, like a low power FM or a full power FM. And so there could be an ISO coupler or what they call a bazooka feed on the tower, where it's quarter wave stubbed off. Just all different things. The base of an AM tower can start to get to be a complicated thing. Rock Scott posts a picture of some Austin rings, and those are something that often require maintenance as well. One thing that because Austin rings are if you don't know, an Austin ring is this transformer. It's an AC power transformer, and it looks like two giant donuts. All right. I mean, they're these two giant rings, and then the rings themselves have windings of wire in them. And the whole idea here is to get AC power from the ground side. And this is assuming it's a hot AM tower with a base insulator. So the tower is hot with RF, and so you can't just put an AC power wire across that insulator. That won't work at all. So you have to have a transformer to get the AC power onto the tower, and the transformer has to have a lot of air insulation between the primary winding and the secondary winding. And so there's this thing called an Austin ring transformer, and oh my goodness, are they expensive? I've never had to buy one, but people tell me they are high. Chris, you probably have ended up buying one or seeing a price of one somewhere along the line.
Yes, every AM station I've worked for, we've had them. They work great. It's the wildest thing to look at. They are heavy, but just basically two huge metal rings of wire and suspended on a pole from the tower and on the pole from the ground. And the air insulation is dictated by the power of the transmission. Yeah, the tower.
Yeah.
And I have seen pictures. I'm trying to think if No, I worked at a station. We did have one get shorted out by lightning. Boy, was that a nasty looking thing with a black hole on that ring. But yeah, they're pretty cool. It's an air transformer. It's basically what it is.
An air, yeah, with a lot of air between the two. I'd like to see them make those things sometimes. It's like a puzzle. How do you get this out of that? It's because these two rings are intertwined. Inside each other. One loops through the other. Oftentimes, your lightning balls, static dissipation balls. What else do you call those things? Spark gap. But of course, a spark gap can be a horn type spark gap. I'm talking about the ones that have, the about 2-inch in diameter, 3-inch in diameter metal balls.
Yeah, they're two round spheres on a pole, and you separate them based on power. So if it's a 50 kilowatt transmitter, typically the spacing is the width of a chief engineer's thumb. That's what I was taught.
The width of it, and you don't test it while it's on.
No, you don't want to do that.
The thumb will get a whole lot different looking.
Yes,
if you do. Well, what my point in all this is that it seems like every year I see a sad story. Rock Scott did not post a sad story, but everybody there's a sad story every year posted where an Austin ring ends up getting destroyed. Why? Because they're improperly mounted. Because of water, rainwater. It's going to rain on these things, and you want water to drip off of one ring without dripping onto the ring below it, or the portion of the ring that's below it. You want to arrange them, and I wish I could show you a picture here, but you want to arrange these things so that when one gets wet, water comes off of it, it drips, and it goes straight to the ground. It drops to the ground. It doesn't drip on the other half of the transformer. And so often, these things are installed incorrectly. And I know I've corrected a couple of them myself in years past at AM stations. Same thing for the lightning dissipation balls. Yes, there's Austin ring right there. Good work. Good work, Suncast. Yeah, and those look like they're mounted basically properly right there, so that the upper one, rain on it, will drip right off and not fall on the lower one. But the lightning gap balls, those also should not be arranged with one above the other, because then water's going to drip off the top one onto the bottom one and either create a short, or people are going to separate them more so it doesn't create an immediate short. And then you've got a problem. Those balls need to be, horizontal or nearly horizontal from each other. They need to be, left to right from each other, not
They have
up
to be
and down.
properly hung.
That's right. That's right. So just I see that every year. Somebody's done it wrong. Another picture that shows up, Stan Carter from Mississippi posts a picture of nitrogen, of a nitrogen regulator, and it's showing zero all the way around. Nothing in the line, nothing in the tank.
That's dangerous.
Yeah. The purpose of the nitrogen is to keep the coax pressurized so that moisture doesn't creep into it. And if you don't pressurize it, I promise you're going to have a problem. So before we break for commercial, one more thing that we see a lot, or that is posted a lot, are pictures of AM tuning houses that where they've just been destroyed by lightning, or they've been destroyed by mouse droppings and mouse urine. Because in the winter, mice are looking for a place that's, please, just a little bit warm and out of the wind. And so they'll find their way into one of these outdoor tuning houses. And for those who've not seen one, they're usually a big box, anywhere from 2 or 3 feet square. I've seen them that are 10 feet long and 4 feet high and 4 feet deep. So they can be any size, but they're a big metal box, typically outside. Newer ones are anyway. Over the years, there've been plenty of homemade ones. And I tell you what, mice will find a way in, and they'll get in there, and they will just poop everywhere, and they'll pee everywhere. And it'll end up being just a big mess. So you got to go out and check those things. And these days, Chris, maybe in New York City they do a better job, but these days with the state of AM radio, I believe there's a whole lot of neglected AM sites out there that if an engineer were to go inspect, it would be pretty scary.
Yes, I've been in a couple of rural areas over the last year and a half, and I had a chance to see some neglected AM tuning boxes, dog houses as they're known by some. And the rodents tend to crawl inside the coil. If you're a daytime only, you usually find out in the next morning, a surprise when you suddenly have power going back, or you're not going on the air, and you get out to the site and there's a carcass that's now splattered all over the coils. I've had that happen too, and it's annoying.
Well, so anyway, point here about bringing up this whole thing about the group is you ought to check into it. If you're a broadcast engineer, there's a lot of camaraderie there, and man, a lot of good tips. I'm scrolling through here. Somebody describes a problem with dead program circuits. Our friend Charlie Wooten from Panama City, Florida. Well, he lost some T1s because a road crew or a fiber crew cut into a cable. Took a long time to get that fixed, and really heroic work, he said, by the AT&T guys. And he said he was surprised and really pleased with the good work there. A lot of stories in I Take Pictures of Transmitter sites of engineers bringing old transmitters back to life. Maybe a transmitter that's been left to decay for a while, and they really wanted to spend some time, to get it back on as a backup. So there's plenty of success stories there and things that can be learned. There's also, and again, we can't show it to you. You can go to the website yourself after the show. Chris Tracy, who's an engineer up in, I believe, Connecticut, and he's provided some pictures of some enormous air capacitors at WTIC. At the AM site. These things, I've seen some of these at the WSM transmitter site a few miles away from here, but these are enormous. I mean, they're as big as a washing machine, and they've got, looks like a dozen or so plates, half of them connected to one side and half to another. And these plates are huge saucers. I mean, like a turkey serving platter. And there's, a dozen or more of them stacked with a little bit of air gap between them, and thereby making a capacitor that handles a whole lot of power. Chris, have you seen those? Great big.
Yeah, it's in Hartford at TIC.
Yeah.
Yeah, it's pretty cool.
Wow.
Yeah, it's a 50 kilowatt up there. Yep.
Well, apparently that design was popular for 50 kilowatts. As like I said, there's some at the WSM site. Hey, at the WSM site, there's also a capacitor. I want to say it's a. It may not be a variable capacitor, but it was supposed to be charged with a gas, maybe nitrogen. Although a vacuum would be better than nitrogen, wouldn't it?
Usually it's a vacuum cap. Yeah, usually they're vacuum caps.
But this one, I swear, had a maybe it was a place to hook up something to pull a vacuum. Maybe that was the idea.
Was it a little glass dimple, or did it look like a glass nipple? Because that's usually when they evacuate it, then they have a little.
You know, I want to say that it's sitting there with a bottle of some kind of gas next to it. It's not in use.
Oh,
it's part of the WSM. You know what we ought to do? We ought to do a show from the WSM transmitter site. I will talk to Jason Cooper about that. And we should just do a show out. I don't think we've ever done a show from the transmitter site.
That would be fun.
It would. It would be a blast. Hope we don't get RF into the microphone. I don't think they turn the transmitter down for me. All right, they actually Gaylord Entertainment is in the process of reworking that beautiful old Art Deco, not Art Deco. It's not an Art Deco design. It's some kind of a classic design, but opening it up as a tourist attraction. You'll have to pay money to go, and of course they're going to cordon off the the transmitters themselves. But that place is amazing. They used to build transmitters there, not only for themselves. They built transmitters for other broadcasters. They build them and sell them.
Huh.
Yeah, they had all the
days.
They had a lathes and a big brake, to form all the metal and the coils, and that was amazing. Well, Chris, think about a tip or a trick for us during our break. We're going to go to break here and talk to you about Lavo and the Lavo Crystal Clear audio console. Everywhere you go, you find touchscreens. There's your smartphone and tablet. Supermarket checkouts have touchscreens. Laptops come with them, more and more now. And so do the radios in new cars. Even airplane cockpits have touchscreens. They make sense because they're simple and natural, and their intuitive controls help you finish tasks faster with less errors. Isn't it time you brought the power of touch to your radio studio? Well, you can with the Crystal Clear virtual radio console from Lavo. Crystal Clear gives talent an instantly understandable multi-touch interface, faders, meters, clocks, timers, talkback, and more. They live in harmony on a single screen. No show can run smoother and sound better than controlling it this way. Crystal Clear features Lavo's exclusive Auto Mix. It's the hands-free smart mixing algorithm designed for fast-paced multi-mic talk shows. And Auto Gain. Just push a button and the preamp calibrates automatically while your guest speaks into the mic. No more clipping at the preamp. With so much advanced automation, talent can dock the mixing controls and use the screen to do other things. Solitaire, maybe. Oh, like working with, seriously, delivery systems, audio editors, or phones. Crystal Clear's power plant, now that's the rack mount part of this. It measures 1 RU. It's pretty amazing considering the staggering amount of DSP on board. Compression, EQ, voice processing, precision delay can be applied to all of your mic, line, and digital sources. Optional upgrades include redundant power, MADI, and Ravenna AES67. And all that power costs no more than you'd spend for an ordinary board. So if you're thinking about a new console, don't decide before you check out Crystal Clear from Lavo. Go to www.lavo.com and read about it. Or in the USA, call Bill Bennett at Lavo USA. Bill's number is 888-810-4468. That's 888-810-4468 to find out more. The future is clear. Lavo's Crystal Clear. I sure thank Lavo for sponsoring This Week in Radio Tech. All right, Chris Tobin, your tip might be how to use Wi-Fi to do a remote, but what you got for us, buddy?
Oh, gosh, I wish I could think of a good tip. I was trying to run through my head, but I guess since we're doing the Wi-Fi thing, the best thing I can offer up is find applications you can run on your smartphone for Wi-Fi spots and checking the spectrum. I forget the name. NetStumbler was the old one that people used to use. And use that as you're traveling around, not for in particular for a broadcast, but just in your travels, like commuting to and from the office, or maybe hanging out for lunch somewhere during the middle of the day, and look at the spectrum and get familiar with what the spectrum looks like. So when you do go to a broadcast site survey and you call up a unit, you look at it and go, whoa, you know what? I know exactly what to expect because I've seen this imaging before. So I would suggest that. I can't think of names of particular apps, but there's a lot of them out there. Or you could, if you have a Ubiquity, you could use one of their units. But there are plenty you can use on the phone in promiscuous mode and look at the spectrum. And you'd be surprised at things you learn. And I say this because when I did a lot of work with satellite downlinks, and when I worked at 2 networks, we did uplinking and downlinking. One of the things the satellite engineers used to tell me was look at the spectrum on the transponder of the bird or the spacecraft and try and get familiar with the spikes, the way it looks. And that way you'll know when you're looking at a scope and you're looking at a downlink or an uplink, you'll know what to expect. So I'm going to take that same thinking and apply it now to today's Wi-Fi. And that's what I would suggest. Look at the spectrum, learn it, understand it, and know that wherever you are, it may change. So like go to a Starbucks, go to a Walmart or a Costco or a Macy's and look and see inside. Because why? Those are locations your radio station is going to go to probably do a broadcast. So those are places you want to get familiar with and see what's out there. That's my tip.
That is a great tip. That is such a good tip. And about the satellite thing, I used to do that. I tried to remember them, and then that was back in the early days of digital cameras, about the time we were doing a lot of satellite work. And so I'd take pictures, and I really appreciated it when one or more of the satellite instruction sets came with a spectrograph. Here's what if you have a spectrum analyzer, here's what you're looking for when you see this, when you see our bird. This is about what it ought to look like. And of course, that may have only been accurate for a few months until somebody else turned up a transponder. But it
still helped. It still helped. It was still a starting point.
Exactly. Well, Chris, thanks for that tip. Very helpful. And I'm just going to close out with this story from Dayton. It got me. It's fake. In what's being called confusing and totally unexpected, about a dozen protesters showed up this morning at the Dayton Hamvention. People advancing the humane treatment of animals, or PATHTA, protested in front of Dayton's Hara Arena, advocating against unsafe hog farming, growing, and butchering practices. "We will make these madmen stop," exclaimed group leader Paula Smith Taylor of Westchester, Vermont. "The unstoppable slaughter of hogs for food and profit must end." A group of ham radio operators headed to the Peanut Whistle Transmitters exhibit to take a look, or to visit with Smith Taylor. She seemed genuinely surprised at what ham radio actually meant, says octogenarian Vince Basco of Cheyenne, Wyoming. After I explained it to her, she told the group to get back in her VW microbus for their next assignment. "We're headed to Arkansas," Smith Taylor exclaimed as the van left the Hamfest parking lot. "We hear there's fighting hogs there, and we must stop that insanity." So, yeah, protesters at the Dayton Hamfest. And I think it's a made-up story, but it's a good one.
Ham, anyone?
Yeah. Hey, Chris, thanks a lot for making that effort to not only tell us about exciting science and technology, but to actually do it. I really appreciate that.
Well, I just want to add in closing that my MacBook was at 100% at the start of the show, and I'm now down to 10% on my battery operation. So I've successfully squeezed out every joule I can. So I am totally LEEDs compliant in this particular netcast.
Good deal. Just be sure you charge it with solar, buddy.
Well, I'll charge it. I'll go to a charging station. That's an authorized station at Penn Station. I think they have these little kiosks. So I'll use that.
Sure. Why not? Go ahead. All right. Hey, thanks a lot to our sponsors, the folks at Axia, folks at Omnia, and Lavo for sponsoring This Week in Radio Tech. Thanks again to Chris Tobin, and also to Suncast, who's the producer of our show, does all the switching up there in New York at the GFQ network, and lots of other good podcasts on GFQ. Let me encourage you to make that a shortcut link on your browser and check out the podcast they have there. And you find something you like, well, download it automatically. You can subscribe to the audio or video of any of the GFQ podcasts. Thanks also to Andrew Zarian. He's out of the office today, but he's the founder of GFQ. I really appreciate his support of This Week in Radio Tech. All right, we got some great guests coming up in the coming weeks. I want you to stay tuned and watch and tell your friends about This Week in Radio Tech. I'm Kirk Harnack. We'll see you next week right here. Bye-bye.